Hi there. Today we're going to troubleshoot this Fender DeVille guitar amplifier. So the problem with this amplifier is, a very short period of time after it's been turned on, it goes into an extremely loud hum situation. You shut it off, and of course it stops, and then you turn it back on, it's fine again for a while, and then it goes into this extremely loud hum situation. Now, supposedly this isn't a very subtle hum, it's like rattle the windows hum. So what I'm going to do is remove this amplifier from the case here, put it on the bench, and I'm going to put it into a dummy load and watch the results on an oscilloscope so I don't have to listen to this extremely loud hum as it shows up. So let's get this thing onto the bench and check it out. Hi there. So this is the amplifier here, and this is my camera about the lens like right in my eyeball here. This is pretty close quarters right now. So at any rate, this is the amp here. This is the inside of the amp, and of course the complaint was that the thing hums. When you turn a thing on, it gets a really bad hum, and then the hum goes away. So what I'm going to do is search for that hum, try and find that hum, and make it as easy to understand on the screen as I can. So this is the amp. This is the inside of the amp. These are the output tubes here, and these are the preamp tubes. This phase inverter, and then two preamps here. There's a couple of op amps in there and stuff like that because it's kind of a hybrid amplifier. That's what they've done in here. You can see there's op amps, you know, here, there, and everywhere. It's a TL072 right here, and there's another one over here. Now this isn't on right now, and keep in mind if you ever do work on something like this, you can't go sticking your fingers in here whatsoever because there's extremely high voltage. You can see these caps here are rated for 500 volts. I don't know if you can see that in the camera. There's a lamp kind of blazing on it right now, but all the filter caps are rated for 500 volts, so you don't want to come across those ever because, well, there's probably pretty close to that across those caps. So whenever you're working on a tube amp, they're not like transistorized amplifiers. This is a hybrid, so it has a low voltage supply in it for the op amps and for the relays and for the LEDs because it has an LED mix. And there's also a high voltage supply because the plates of the vacuum tubes need to have a high voltage on them in order to cause the electrons to flow properly in the tube off the cathode and get attracted to the plate. So that's why they call it B+. It has a lot of voltage there. So what I'm going to do is I have a high-tech oscilloscope here that I'm going to use today. I'll show you that right down here. It's extremely high-tech. It's the newest in DSOs. It's a 5 gajillion gigasamples per second. Actually, no, it's not. But it's a pretty good little old scope, and we're just going to be looking for AC because it has a hum on it, and the hum is about 60 cycles. You can hear it, and it's maybe. Well, it sounds more like 60, yeah. So I haven't actually measured the frequency of the hum because it's really not important. So what we're going to do is look for that hum, and the first place we're going to start is the front end tube, which is this guy right here. So this is where the signal starts, comes in from the jacks, goes into this tube, and then through some clutter on the circuit board here, and then into this tube, and then through some clutter again, and then into this tube, and then it goes from this tube here into these two big output tubes that I pointed to you here. These are the guys that drive the speaker, and I have the speaker into a dummy load, which is an 8 ohm, just an 8 ohm dump. It's just a dump loads, big resistor here. So that way, if the thing does start to hum, I don't get 50 watts of 60 cycles in my face because there's two very large speakers right here. Then that's also the reason that I had to put this little oscilloscope over on this bench over here, is because the magnetic field from those speakers is so big that it twists the trace on the screen. So that's the reason it's over on the other bench there. I would have it here, and it would make it a little bit easier for the shot. But yeah, I need to put it over there because if not, I'm going to be looking at a crooked trace. So what we'll do now is I'll turn this thing on, and I don't know if you'll actually be able to hear the hum. So I'll turn it on, and it has to warm up because that's how tubes work. Tubes have to warm up first in order for the electrons to start flowing. And the standard warm-up time for a vacuum tube is 11 seconds. That's for an indirectly heated vacuum tube. That means that there's a cathode, which is like a pipe, and there's a filament inside there, and that warms up the pipe on the outside, and the pipe emits electrons, whereas a directly heated cathode is just a filament, and the filament itself emits the electrons. So all the tubes in here are indirectly heated, and so that means that they have a little bit of a warm-up time. So the thing's on. We'll take it off of standby. There's a standby switch up here and turn it on. Okay, and we'll turn the master up. You can hear it humming. I don't know if you can hear that. So it's pretty loud. I'll move the microphone there. So when I turn the master up, it starts to hum pretty bad. Here, I'll just put it by the audio transformer. You can hear how bad that's humming. That's a lot of noise in there. So we're going to start at the vacuum tube in the front end here, which is this guy here, and we'll look for the hum at that point. So I'll turn it up just a little bit. So it's intermittent and it does go away, he tells me. So I can just hear it humming with my ear now, which is kind of nice. It's not putting out a massive amount of wattage, because if you have this thing humming completely loud inside this resistor here is going to be absorbing 50 watts of 60 cycles, and that resistor won't like that very much. So it's just low level. So what I'm going to do is look around on the pins of the vacuum tube. Now we know that pins 4 and 5 and 9 are the heaters of all the 12 series tubes, the 12AX7, 12AT7, 12AU7, 12AY7, 12AV7, 7, yeah, there's so many of them. So they're all, and all the pinouts are the same on all those tubes. So what we're going to do is, I have this pinout here. I'll just turn this on to standby here for a second. Actually, I'll just shut it down to keep it cool so that it doesn't go non-intermittent on me here. So I have a book here. I'm just going to look up in the book, okay, the pinout, 12AU7, that'd work, but just for, is that cleaner? No, that looks good. So 12AX7 is the tube here. We can see the tube right here. So that's the pinout for the tube that you see right around here, okay? Now you always count clockwise from the bottom side of the socket. So if you're looking at at the pins, you're going to count exactly this way from the bottom. So you look at the index, which is the tang here. This is open. You see there's a space between these two pins, and you count here. And hum is usually caused from heater to cathode leak in these tubes. So that what happens is the heater in that sleeve, what happens is the actual filament is run on AC. It's just raw AC on most amplifiers. Some more of the higher end amplifiers, they run them on direct current. But in most of these amplifiers, they're all AC filaments. So that twirled up filament inside that sleeve is raw AC, and if there's any leakage between that filament and that sleeve that it's tucked into, and it's a pretty tight tolerance, because if you think about it, if you can just picture a pipe with a wire inside of it, right, and the only thing that's really insulating it is the coating on the filament, which is a really hard coating. If that breaks off or chips away and it touches the pipe, that leaks AC right onto that. And if you have any kind of AC on that cathode, it's going to amplify it like crazy. So especially in a high gain front end. This is the first tube, so there's very high gain at that particular tube. So what we're going to do is we're going to look for a leak onto the cathode. So we're going to look for some high level AC signal on the cathode. So when I attach this little oscilloscope here, I should pretty much maintain a flat line. I shouldn't see anything more than that when I touch the cathode. If I see any kind of ripple on there, or if I see any kind of like a sine wave, we'll know for sure that there's a leak on there. And if we go to the corresponding plate or anode of that tube and it's really big, then we know that that particular part of the triode, because there's two triodes in a 12AX7, that particular part of the triode is leaking. So that means that there's a heater to cathode leak. And that's sometimes very easily found in a tube tester or anything like that. But since this thing's on the bench, we'll just look for it here, because it's a pretty common problem. You got to remember that these tubes are hanging inverted in an amplifier with two monstrous speakers right in front of it. This big speaker here, and there's another huge one right here. And these tubes are actually just shaking like crazy when people play any kind of electric guitar very loud or anything. These tubes really get a workout. It shakes the crap out of them. So, and not only that, there's a lot of things in this design which are kind of crazy. I mean, they're great amps and they sound wonderful when they're running, but they're pretty hard on their parts, especially if you've got some young fella jamming on his guitar at 50 watts, and this thing is just you know, everything in here is just swaying. So that's pretty much how these things, they go through tubes pretty easy. And believe it or not, there's a lot of hearsay about Chinese tubes, and they say that, oh, Chinese tubes are garbage and this, that, and the other, and actually no, they're not. If you take a new old stock American tube and you look at its internal structure, and you take a new Chinese tube and you look at its internal structure, the Chinese tube is built quite a bit stronger, and it's just for the reason that they know they're going to be stuffed inside these things, and if they build them, you know, back like they did in the old days, they get really loose inside and they get microphonic. And what they've ended up doing in a lot of these tubes here is the cathode, there's a mica spacer on the top of the tube, okay, and then the cathode pokes through that mica spacer, and then the grids poke through the mica spacer, and then the plate is got kind of pokes through it, and then they usually just twist two little tangs on the top to hold the mica spacer on the top of the triodes. Okay, so what happens is from vibration, like in a situation like this where the thing just, you know, you hit your guitar and it's going, bah, right, you know, that is just shaking these tubes like crazy. And what happens is where the grid posts stick through the top of the mica spacer, what they do is they vibrate so bad that they end up making that hole in there very sloppy, and what happens is that whole grid aperture shakes inside the vacuum tube, and hence you get a microphonic vacuum tube. Now the Chinese people are pretty smart, and what they did is they actually put another mica spacer on top with little tangs that put tension on the post, so they actually push on the post sideways. So the old American tubes never had that. They just basically poked through the spacer and that was it. So there's a whole bunch of new techniques that they've come up with to keep tubes from getting non-microphonic, and that's one of them. And they really do stand up, because I've replaced lots of American tubes with Chinese tubes and vice versa. And the Chinese tubes, for all you American vacuum tube believers, believe me, the Chinese tubes do last quite a bit longer in a high vibration system like this. So now, you know, we could get into the talk about psychoacoustics, and, you know, American tubes sound better than Chinese tubes and all that, and the bottom line is they're an electron valve. And I'm not going to get into the psychoacoustics end of things today, because that's a completely separate topic, but I'm telling you just from personal experience and from what I see inside of a vacuum tube, the Chinese tubes are built pretty robust. So anyways, enough of my spiel here. So what we're going to do is I'll open the book back up to 12AX7 here. This book is pretty busy, and it's always fun to find tubes in here. So 12AX7A. So if we look here on the actual pinout, we'll see these two little, they look like C's on the bottom. Those are the cathodes, okay? And the little dotted lines are the grids, and the two kind of like T's here, you know, right here and right here, right on the top, this guy here and this guy here is called the plate. And what happens, these are two separate units. There's one triode there, and then there's another triode there. So there's two separate units inside this vacuum tube, okay? So what we're going to want to do is look at the cathodes. So I can't see in my screen where the cathodes are because it's too small. So pin 3 and pin 8 are the cathodes, KT. So we see pin 3, right? And then we see pin 8 is the other cathode. And that's what we're going to look at. We're going to try and see if we can spot any hum on any of those, because that's, as I say, the filament is directly within inside that sleeve. So let's check it out and see if we can find any leakage on there. So I'll turn this thing all back on. So now I'm going to probe in here with the probe, and I'll move this over so that you can see the scope. And I'll turn this up, see if we can get some hum going on here. Nope. No hum. And so we'll turn it back off. And wait a second, because this is an intermittent problem, by the way. My microphone's still holding out, which is a good thing. Okay, here we go. Let's see if we have any hum. Come on, you can do it. I'm going to pause this, and I'll try and get it to hum, and I'll come back so that I'm not wasting all this footage here and boring you guys to death. Okay, we've got the hum. So now we're going to look at pin 3 and pin 8. Okay. So we've got 1, 2, 3. On the oscilloscope, we can basically see nothing there. So let's go at pin 8. Whoa, there it is. That's on the very first tube. So I'm just going to pull the tube. There we go. Well, that was too easy. Plug it back in. Oh, there it is. I'll tap it. So that's pretty much hands down a heater to cathode short right there. Okay, so I'll remove the tube. It seems to do it when it's just as very first warming up. So I got the probe right there. Okay, just letting the tube cool down right here. And I'll plug it back in. Okay, it's plugged back in. That'll be warming up right now. There it is. I'll remove the tube. All right. Just letting it cool down again. And we'll plug it back in. There it is. Remove the tube. So there it is. So we can pretty much tell we've got a heater to cathode short right on this front end tube. Well, that was kind of easy. That was almost too fast. So this 12AX7 right here has a heater to cathode short. So what we're going to do is get another tube and pop another tube in there and check it out. Okay, here I have a brand new Behringer tube, 12AX7. And we're going to plug it in, just like so, and we'll watch. Okay, that should be warm about now, and it's not doing anything. So what I'll do is I'll pull this tube out now. Okay, and I'll keep the probe on that socket, and we'll plug in the old one, and we'll see what happens. Okay, there it is. So I'll unplug this tube. All right, and put in the new one. And dead silent. So we don't even really need to stick that one in the tube tester to even see that it's leaking or that it's shorted, because we can tell right here just by using the scope and in the actual unit to locate that it has a heater to cathode short. Yep, so that tube is absolutely fine. So that gets rid of the intermittent hum issue. So now there's one other issue, that the channel select on this thing doesn't work. So it does with the foot pedal, but the channel select does not work with the with just the button on the top. Here's a channel select button right here, and the camera is a little bit low for that. See, right here is this is the channel select LED. All right, and there's a channel select button right here, and it should move a relay in and out when I push that channel select, and then that channel select LED should turn to a green color, and it's not doing that. So I'm going to grab the schematics, and I'll come back, and we'll try and trace out why the channel select isn't working. So One problem licked. That was actually really fast. I was hoping to do a little bit more of an in-depth procedure here to show you how this is done, but what do you do? It just went that quick. So we'll look at the other one, at the channel select issue when I come back. The second issue here is that the internal channel select switch isn't working correctly. And we can verify that by looking at the light here. See this little LED up here? It's red. When I press the channel select switch, it should change color. It should go green, and then, or they call it yellow, but it looks pretty green to me. And then that should go back to red again. So I'll press the button. You can watch it there. There is no change. Now the catch here is when we hook up the external foot pedal, it works normally. From the foot pedal, of course. So here's the foot pedal. You can see here. See the goes green. See it goes green up here. Red, green. All right, and we can see that, you know, the functionality, I can hear the relays clicking inside, is normal. But now we can see that this here is, you know, off. Turn that back on. Red, green. We see the green here. Okay, I'll disconnect this. Goes back to red again. And when I press the channel select switch, there is no change. So already this is pointing to a particular component here, and I'll explain how I've come to this. If we look at the schematic, this here is the selection area, okay? This is the jack, this is the foot switch jack on the top. So we see inside here that little arrow on that piece there, that's a switch inside this jack. So when we plug the jack in, it separates that switch and allows the voltage to go out to that foot pedal. And the foot pedal to take control. When you take the jack out, these two little pieces here should reconnect, and the voltage should go from this end of the resistor here into these diodes, okay? And how we can verify that is we'll test this end of the resistor. It should be at 27.3 volts or thereabouts. And then we'll verify the voltage at this end of the resistor. And then the voltage that is at this point should also be at this point here. So that's going through that switch and going into the top end of these diodes right here. So going into the top end of those diodes, we just really need to find, you know, this end of the diode here, and we'll find this end of the resistor. And we'll verify and see if this switch is making connection. Okay, so we'll do that right now. So this resistor up here, this guy here, is 820 ohms. And it's R91, which is, or R97, sorry, which is this guy right here. All right, so we'll touch this end. We have 27.5, 27.49 volts we can see on the voltmeter over here, which is close enough. And then on this end, we have 10.2 volts. 10.19, 10.2. So we know that the 10.2 volt side is this side right here. So we can see it should be going through the switch right now and ending up at the diodes. So what we'll do is we'll look for these diodes here, and we'll test this end of the diode. So this is the section over here, and the diodes are CR21 and CR25. And this is CR25 right here. So CR25, the line side of the diode, or the cathode side of the diode, is attached through that switch. So what we read here, okay, right here, 10.2 volts, should be present right here. And it isn't. There's 123 millivolts there. So we know that there's an open connection between that part of the resistor and that diode, which is basically either a trace, a bad solder joint, or the switch inside that jack. So now I need to get into that jack or onto the other side of the circuit board to verify all of this. In order to do that, I have to remove all these nuts, I have to remove all the chicken head knobs, I have to remove all the nuts under the chicken head knobs and these two nuts, and then this will drop down and pull forward, and I'll be able to get behind there, and that is kind of a time-consuming process. So what I'll do is I'll get the circuit board moved out, and I'll end up checking it at that point. Keep in mind that while I was doing these tests, the unit is in standby. The standby switch is just turning the B plus on and off. It's not turning on the low voltage supplies, so you don't need to actually have the amp working, and you don't need to have that high voltage there. So I'll end up removing this and come back, and we'll assess it from that point. So we're going to remove the jack now. Okay. They've bent these two guys here together just a little bit in order to give it some tension, I guess, to hold it in for actual assembly. And then this is the bottom one here. They've also got this kind of two fingers on the bottom like this, and they kind of spread them apart and they kind of hook onto the chassis. You gotta push them together a little bit to get them out. So there we go. That's it, and that's as easy as it is. So you can see how they've kind of got those little fingers there. They spread them apart. That kind of holds it in. So you got to pinch them together a little bit. And away it comes. So this is the faulty guy. So it looks like it's sealed up on the top here. But I can see directly inside of it. It doesn't look like anything's broken. It just looks like the contacts might not be touching. So I'll try and open this up, and I'll see if this can be repaired, and if not, we're just going to have to replace it. Here's the foot switch jack removed from the circuit board and ready for disassembly. So what they've done here is this black plastic case has a bunch of extrusions that stick through this clear plastic top here. And what I've done is I've just ground those extrusions off. So what happens at the factory is these stick up through the plastic lid, and they have a machine that heats them, and they press them down and it kind of mushrooms over this plastic. So you just grind these little extrusions out, and then this plastic cap just comes off with ease. It can be reapplied with a little bit of super glue and it would be just absolutely fine. So inside here, this is the switch. This little white insulated lever here that pushes in like so. You can see that arm in behind here, this little metal arm, is supposed to make contact with this piece right here. And it's not making, because it's stretched too much, and I can see that there is no contact between it. So this comes apart very easy. If you clean off the solder on the pins on the bottom here very well, you can see here that just push things out. The whole thing just really just comes apart quite easy, just like so. So the arm on here is a little bit bent, so I'll bend it straight and put some tension on it. There's a lot of spring tension left, and this by no means is bad. So we'll put tension on that, and then that will make contact right to this little part here. You can see on here. This little piece here is where that arm touches, and it'll be absolutely fine again. Now, if you have the whole thing apart, it's a good idea just to put a little bit of tension on all the parts that need it. This little kind of a hook here, if you can see that. Try and get that into the camera light the best. This is another little piece that can have some tension. I'll get to that in just a sec. There's a little hook here. You can press that down a little bit so it makes contact to the barrel a little bit better. And then this little piece that came out, you can see it already has its own little spring in the bottom here, but you could open it up just a little bit, and this of course has a little bit of a curve to it also, so it could be straightened up, and this would be good to go for a very, very long time. So just reassemble it, and we'll have a good jack that should be just about as good as new. The amplifier is finished now, and the circuit board is reinstalled. When you're reinstalling the circuit board in here, and you get all the shafts of the potentiometers poking up through, so you can put the knobs back on and such. What you want to do is tighten up the nuts on the shafts of the potentiometers first before you go tightening anything else. So tighten these guys up first, and then put the nuts back on the jacks here and snug those tight. Remember, these are plastic, so don't tighten these too much. And snug these tight. And then once all of these are tight, then put all of the 632 screws back in here. If you tighten up the 632 screws first, you're going to try and stretch the potentiometers off the board. So by tightening all of this up first, pulls it taut against the chassis, and then it's just tight down in here. So if you're putting it back together, that's very important. Sometimes you'll have to, fool with the switches to get them to come through the little square slots here and make sure the LED comes through when you're putting the circuit board in and everything. You want to make sure everything just fits perfectly before you go tightening anything up. There's an LED has been added to the jewel lamp here, so there is no incandescent bulb in there. And the reason that has been done is because amps that are played loud, it vibrates the filaments and the bulbs burn out quickly. So by putting a high brightness LED in here, eliminates the need to change this bulb ever again. There's a little bit of a circuit modification you need to do. You have to add a diode and a filter cap, and then just a current limiting resistor here, and you're pretty much good to go. So with this LED, what I've done is I've used a 1N4007 and a 35 volt 470 mic filter cap, and I've isolated it so the wires come, you know, they still are, there's no ground connection here whatsoever. The grounds are isolated. So the two AC lines come up. One goes into the cap, and which is the negative side of the cap here, and then one goes into this side of the diode here. It gets rectified, and that's still isolated from the chassis at this point, and it's its own positive and negative that run up here to the lamp. So there's a 560 ohm resistor here, which is the current limit resistor, and it limits the LED that's in here to about 10 milliamps, which is really quite conservative, and that LED should last forever. It's really bright, if not brighter than the factory incandescent bulb, and it looks just like it. So that's the circuit there. It's a very simple little circuit to add in. All of the circuit boards, the tube sockets have been resoldered around the pins. Now these are single-sided circuit boards, and being single-sided circuit boards, they don't have plated through holes. So by not having plated through holes, you know, they're pretty tiddly with vibration. You know, they crust up and volcano after, you know, the tubes are vibrating or moving for any long period of time. So they've all been resoldered. All of the potentiometers have been resoldered on the back side of the circuit board. All the jacks have been resoldered, switches, everything has all been resoldered. The ribbon cables have been resoldered on the back side of the board. And the reason that that's done is because, you know, you're continually moving these, and these often come loose on their own. And like these jacks were very loose, and same with all of these were very loose, and that causes the solder joints to come open on the back side. So they've all been resoldered, so you know it's like brand new back there. They're all nice and tight, and you don't have to worry about that coming loose in the future. And it's the same with these. If you've ever moved the circuit board in and out, you want to just resolder all of these and make sure that they're nice and tight. Now the bias has been reset also, and that's a very easy procedure. This is the bias set potentiometer right here, and all you do is you clip your negative of your voltmeter to the chassis, alright, and this here is the negative bias set point. So I'll focus the camera down on my voltmeter down here, and you can see when I touch the, maybe I can get the negative bias set point in there too at the same time. So you'll notice here that when I touch this, alright, it should be at 60 millivolts. You can see that, 60, 61, that's very close. And the tubes will move as it gets hot, so don't get too crazy about that. Let it warm up, and of course, you know, if you know that the bias is somewhere near where it needs to be, let it warm up at that point, and then just set it at that point. So we're, you know, 60, 61. And the reason that you see the fluctuation in there is because I've got other pieces of equipment turning on and off around here, and it's causing the voltage to sag and go up a little bit. So that's where it is. So you set this little blue potentiometer here, you turn that until this says 60 millivolts, and your bias is set. And that's how that works. So this is pretty much finished, this entire amplifier. I don't know what else I can tell you. I'll show you the LED is working on the top here. You can see this LED wasn't switching before. You can see it. You can hear the gain kick up there. And then we have that, and then we have the drive, and it does the normal and more drive. So that was all just because of the contacts in this jack over here that we fixed earlier were bad. Now everything's making connection and everything is running through, and the unit is back to normal again and works quite well. And that's really how you service one of these amplifiers. So that was the only problems with this one. Of course, you know, all these amplifiers, they all crop up with all sorts of different kinds of problems, but this is all pretty standard stuff. Burnt out dial lights and setting biases and you know, noisy tubes is a pretty common thing. If you ever do get these in, just, you know, keep in mind that there's always high voltage in here. Right now there's, you know, an excess of 400 volts in here, and you never want to come across that. So if you ever work on these, remember you're doing so at your own risk. Be very careful. Don't ever come across these caps here. You'll really regret it. So I hope you enjoyed this. If you did, stay tuned. There'll be more stuff coming up next. Bye for now.